So I'm going to hand over now to Wolfgang Ecker, the principal engineer.
Yeah, thank you. Good morning. Let's see how this works. As you have seen, we have some problems with the infrastructure, but as I'm used to use EDA tools, that's not new for me. Just to say some words up front, I'm not covering things here which are natural for me, so to say, for example, good tool quality. And one remark to EDA, we still suck a lot of things due to bad EDA tool quality, that things doesn't work, that should work, that supported features aren't supported. So we lose there a lot of things, but since resolution is natural, that you get a quality, high quality tool, I just don't mention it here. Yeah, unfortunately EDA isn't there that responsive here. So, top three verification challenges. So it was hard to select some of them, but yes, let's start. So, what's number one? It was a little bit introduced by Harry in the initial talk. One challenge we face is that we have to link the design and verification process closely with requirements engineering. But requirements engineering is not just writing down things. Requirements engineering is also a refinement process and is a feedback process to our customer. That means with this feedback process to a customer, the infrastructural challenge, the verification challenge gets much harder, because our customers want to have a feedback on what we are doing, and they might use a completely different EDA environment, completely different tools, completely different things, but they want to have feedback. So, but before saying why do we need this, there are many standards out which try to make our life more safe, not insurance company standards. So, for example, the functional safety standard ISO 26262, which is very important to this is a pointer? Yeah. To prevent bugs like this one, so that a child is killed by an airbag sitting on the co-driver seat, or the some driver assistance doesn't work perfectly and you just dump into your neighbor's car. You can say we need this requirement engineering to validate the verification, or to validate the validation. What's meant by that? Validate the validation, the verification. We said, are we doing the right thing? So validation means, are we doing the right thing? And in verification, are we validating the right thing? That means, is everything what needs to be verified, is it verified? And also due to the high productivity pressure which we have, is are things not verified that need not be verified? So if you verify things which are not needed, I spend some time for nothing. The next thing is requirement engineering. Link to requirement engineering helps to improve verification productivity at a higher level. Not thinking about verification IP, really thinking about complete verification solutions. If I have some bunch of requirements which I have verified in a previous process by this metrics, by this environment, by these test cases, I could reuse everything in my new product. But what I need is here a clear structured requirement where I can trace what I did before and what I'm doing now. Then the good story, of course, every company has a clear specification process, and the specification is frozen, nothing changes, and at the end we do implementation and everything is fine. So with theory, and in this theory everything works fine, but as you are in reality, We have often late changes short before tape out over customer wishes and, oh, we got from the technology guys that you have to do this and that. So we have to keep track of changes. And we have to efficiently keep track of them because they may pop up quite late and may have a huge impact. Without having a clean requirement engineering in place, what we're doing there is some gambling, so we might fit the new request or not. And last but not least, we also might do some impact analysis. That means what could be changed if this requirement wasn't there. So whatever I got the requirement from the customer, and then I could say, hey, if you want to do that, this makes your product 20% more expensive. And then the customer could say, okay, do I need this really? Or is it just fancy, nice to have? And having this process in place would help here there a lot. I hope this works. Give you an idea why I draw this requirement as some net, so quite hierarchical net, because there is no clear top-down way that a requirement on top exactly matches one requirement below. No, it's heavily interlinked. You may even have crosslinks over several levels so that the refinement is even done in a later design step. What I also want to give you is that this requirement engineering in this whole process is much more than just linking coverage to requirements. It's starting the verification process much earlier. When doing requirement engineering, you're doing your verification. The next thing is a little bit illustrated by that one. So who is eating up what? So what's the problem there? Also there, the idea is we have an ideal process. Again, top-down is clear. I have my virtual prototype, I do verification there, and I bring down my modules, and then when I can reuse everything I have there, and that's not true. Yeah. We have existing IP modules. Often I have a clever idea of doing a new AD converter which enables a new product. That means I have some bottom-up strategy when I get some IPs from external. So I need a methodology which is seamless top-down and bottom-up, yeah, which allows me to reuse test cases from TLM at RTL, which allows me to reuse RTL test cases at TLM, to include software in the verification process and so on. Which means, that's the true issue, we need an environment which supports all languages, but because VP is System C, RTL is not System C, at least usually, so everything should work together in one methodology. And when we have a methodology thing, what do we verify? What do we verify at what level? And can we guarantee that this holds then for all levels? The third challenge is this one. Yeah? All these animals are playing soccer. Yeah, so maybe they don't use the same ball, but so flea, a small cat, and an elephant. And now assume you really want to watch a soccer match, or these three really have to play together. And when you have at least a little impression what we have to do to verify mixed signal, analog, digital, and software systems. And what's the driver there? The driver here is analog goes digital, but we still have analog, so don't worry, it doesn't go away. Digital goes software to have a flexibility, to avoid respins, and what I said, the world around us remains analog. So the big thing here is to bridge with different domains with different magnitudes in real-time virtual time. So to say, to establish a soccer game with a flea, a cat, an elephant. And there we search for things like what's modeled at which level, how do we model our analog device for software verification, how do we ensure that this high-level analog model matches the low-level analog model so that it really works out, can we reuse software at the analog level, and all this stuff around.
Thank you. There's a question. you have any questions for Wolfgang? This is an easy one. You stand up and
Okay. Just so you mentioned reuse from top to bottom or bottom to top, but you were also mentioning you were not verifying the same thing at different levels. So what kind of reuse you're willing to achieve since you're not concerned by the same thing, verification?
To give you an example, if you write a virtual prototype of some IP, which doesn't have all functionality which you have on RTL, or at a higher abstraction level. Now to verify this virtual prototype at TLM, request for me to do some things which I could reuse at RTL, to do something which I don't do at RTL, because this whatever non-blocking transaction doesn't work at RTL. At RTL we have another mechanism. And I lack something, so some detailed timing, for example. I couldn't assure timing at VP if it's not timing accurate. Another point is how to reuse things on over this level.
Okay. Thank you very much.